Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 400. Find Subarray with Bitwise and closest to K. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I think this one's a little bit sad for me in the sense that apparently someone told me that it was very Googleable. So a lot of people solved this. You can see 2,000 people solved it. I don't think it's super hard anyway, but it's it's Googleable, so, and there's a lot of cheaters. So some combination of those things these days, which is standard for Leetcode. But there are a couple of ways to do it. I want to go over the way that I evolved. I actually got a couple of wrong answers because of time limit exceeded. But also I was just very sloppy on this sliding window, to be frank. Yeah. The first way that I tried to do, I actually did try to use sliding window for a while, but I was running into issues and I couldn't quite clean it up until after the contest, or it wasn't after the contest, but it was after I finished submitting. So the first way that I actually submitted was with binary search, and I actually got this to pass, but the idea is very I want to say. The idea is straightforward in a way, but let me explain it first. The idea here is that you need to kind of play around with Bitwise N, and the thing with Bitwise N is that given a subarray of numbers, it gets smaller as you add more numbers, right? For example, if you have and another thing with bitwise operations in general is that all the bits are independent of each other, right? The powers of twos, if you will. So I'm just going to do it with ones and zeros, so you can think about it, right? Because then here, every subarray is going to look like this until it finds a zero, and then it just it doesn't even matter what the rest of the thing is, right? Because it could be one, it doesn't matter. That means that everything is going to be zero. So that means that as you increase more, so that means if you bitwise and more numbers, that's going to give you a smaller number. So basically, based off this idea, I did a binary search for every number. So I'm saying that for every starting index, I'm going to binary search to get to the rightmost index that gives us the number that we need. And that's basically what I do here. The tricky thing is calculating how do I get the subarray bitwise n? Well, in a fast way, because if you have to do a for loop, that's too slow. Well, the way that it happens is that with prefix sum, because another way of saying if this bitwise n of this segment is going to be it's 1 or 0, is also equal to, that means that it is a 1 if they're all ones, right? So that means that another way to ask this question is, given this subarray, are there m ones where m is the size of the subarray, right? Hopefully, for example, the highlighted thing here, I have 5 elements. So if I have 5 ones, then I am able to, and that subarray ends to 1, bitwise end to 1. And of course, now that you're thinking about these counting things, then now you can do a prefix sum on each bit. And that's basically what I have here. Here I count for each, I do a prefix sum. I add if this bit on the jth is set, and that's what I do here. And then here, as a binary search, I binary search from I to mid. So I binary search from I to mid, and here the good function is just summing up all the ones, right? Like I said, if this is the number of ones inside that segment, this is the size of the segment. If they're equal, that means they're all ones. So then we just set that bit to true, and then we return whether it's greater than k, and then we do a binary search. And this will give us a number near it, so I just count for left minus 1, left, and left plus 1, just to see if it works, or 3, and it'll be fine. So this one is very close. It gives me time to exceed it. I converted to C++, it works. There is one optimization that you can think about this one that I actually was thinking about this, but I just didn't want to implement it. Well, or rather, I would have implemented it if this didn't work. But since I got it accepted, I was like, okay, I don't need to implement it. But the idea here is actually a pretty cool idea, right? Because, okay, so yeah, binary search is the same idea with binary search, except for another way to, oh, I deleted this. Instead of binary searching for everything, instead of binary search, keeping in mind that we have a lot of bits, right? So we have, this is, I don't know, this is the first bit. Let's say, you know, we have a similar thing for the second bit. I don't know, right? Maybe I'll just let me just write random things here, right? Right. So you have all of these, and keeping in mind that the one number is the vertical, so that I could do it this way. So the idea here is that, let's say we're starting on here. Instead of needing to binary search every time, we know that it can only change values in a number of places, right? Because basically we only change values when it goes from a 1 to a 0, somewhere within a 1 and a 0. Or in this case, our next case, or maybe another way to phrase it is the next 0, right? So in here, the next 0 is going to be here. In here, the next 0 is going to be here. So you know, and next 0 is here, next 0 is here, right? That means that for every bit, there's one place in which the value changes from a 1 to a 0 when you extend to the right. And that means that there are only 32 or whatever number of bits of places that it can change. So if you're able to keep track of where, if you pre-process where the next ones is, then you should be able to solve this in a fast way as well. And I'm going to take this time to live attempt to solve this to explain what I mean. Yeah. So okay, so we have the counts here. This gives us the thing that we talked about, but then now we want the like a previous thing of, you know, I don't know, n times 32 or b, the way that I have it. And then now we can also go maybe that's a thing, but it just gives us for each bit where's the next place that gives us, right? And here, of course, we're counting the next. I wrote previous for some reason, but we want to go backwards, so that in here we go, okay, the last element for the first bit is going to be 1 and so forth. Actually, we don't even need this because we can just shift the bits the other way, which is for j in range of b. Then now we go for I in range, and we go backwards. And when we go backwards, we go, let's say, previous is equal to n, right? So then here, previous of ij is equal to previous, except for if num sub I, so if on this bit it is a 0, if this is a 0, then the previous is going to be equal to I, right? And then now we just keep on going, and this will give us the next, let's call it next 0 then, yeah. Something like this, right? So then now it gives us the next 0 of this. So now instead of binary search, we can just manually count all these, right? Because then now here we can say yeah, we can do next 0 of I, and then j will give you all the indexes. So here actually this is already a list of all the indexes. So then we put this in a set, right? So then now for write in this, we don't need the binary search anymore. We don't need this anymore. Yeah. What? Okay, no. Yeah, this is right +1. I guess just to make it easier, this is also, this is left. And yeah, and then now for each of these, we test the best, and that should be good, hopefully. If I don't go out of bounds, apparently. Oh, because this can be n. Maybe n-1 is fine. I don't know. Yeah, and then now we could give a submit. Hopefully it's fast enough. Hopefully Leetcode servers. Oh, that's actually surprising. This is pretty. I don't know. Python stuff is very silly. Because this should only have 32 numbers. So then it just ends up being 32 times. Oh, I see. Okay. I see why. I actually watched this a little bit because I'm doing it live. But yeah, this has 32 numbers. This has 32 numbers. So then now it becomes 32 square, which is a little bit too slow. So what we can do is actually sort this. I mean, so what I want to do is do some sort of sorting on the indexes, but then also incrementally give us the index, right? So how do I want to do this? So then next 0 of I. So then if we enumerate it, then we have for the index, the next index, and then oh, the bit. So the index is the bit. So B as in bit. So then now we can then this B, and then we sort this. So then now we can do for index B and sorted this, right? Yeah. Wait. So now we're going from in and out. So that means that the next 0. So then yeah. So then now we can do something like this. Current is 0, 0 for J in range of B. If current is just equal to num sub I think. And then now we remove this index. So we don't even need the. We don't even need the index anymore. We just need the bit order to get the possibilities, right? So here we don't even need the B anymore. But we needed it to sort it so that it goes in that order. But yeah, and then now we just we just subtracted. We remove this bit, and yeah, and then now that's good. The sorting is kind of awkward, but you're only sorting 32 numbers. To convert it to a list. Oh, no. Oh, whoops. I'm a noob. Is this fast enough? It definitely is faster, but it also gives us the wrong answer, which is not as great. Just want to check that real quick. Huh. Oh, because because it assumes that this is possible, but it might not be with its n. So we want to remove this if it's n. So Clearly I'm doing it wrong, but the idea is right, I think. It's the same as the binary search, except for you want to go to certain places. But apparently I suck at coding. It works on these cases, but we can see with next 0 is right. So 0 is itself, so we don't have to care about all these numbers. That's true. And then it goes to 1, and then it becomes 0. Right? I mean, I'm just trying to audit this, but it's kind of tricky. So 2, the next number is going to be 4, that's fine. 2 is all true as well, which makes sense. This is 4. The third bit is, yeah, that makes sense. So I think I am. No, I mean I definitely have at least one. I don't know. And is it even fast enough? I don't know. Oh, well, definitely not if I print out too much. I mean, it's still pretty slow, to be honest. Though I might just convert it to C++ if I had to do it. I think this part looks straightforward. This looks okay. This looks okay. So I don't know. I wish there's another case. I'm going to just submit it so I can maybe get an easier wrong answer. I know that this is wrong, but I want to get an easier wrong answer so that I can debug versus whatever it is. See? Easier to debug, even if it took a while anyway. Okay, so output is 8. We don't use this anymore. Okay. Oh, I still have that crazy big case. But yeah, we'll go over the sliding window solution too, don't worry. So 1, it goes to Why is that? Why does it print so much stuff? Oh, because it does it with itself. Yeah, that's right, that's right. Okay. That makes sense. So then now it goes to 0. Okay, fine. Yeah, that's for the case it goes to. Okay, fine. So then 2, it goes from 2 to 0, which is true. Let's look at the 50 case. Well, my answer is 8, but you could get, apparently the answer is 10. So what is this? Expect is 40. So that means that 50. But how did I get 8? Dun dun dun. 16 is already close. No, it's 40, right? 40, so 8 is going to be 42 or 5 or whatever. Or 48 or 32. Where do I have 32 or 48? Let's see. That's awkward. Let's get rid of these for a second. One is 48. Why? So it starts at 50. So it goes at 50, it removes all the other things, and then it removes 1, which is 40. Oh, what? What's 50 again in binary? It is too lazy to figure it out, so it's actually this number. So then at some point, that means this, right? Oh, I see. Wait, no, I don't. Oh, no, I see. I have to, I see. Because basically the reason why I'm getting it wrong is that um, if we have the same index, we have to do them all at the same time. Okay. Man, why is this so annoying? Okay. Um, so it groups by index, and then now we have the index, and then the G, which is the group of bits, and then we have G. So we have T is, I don't know, this is a random thing for X in G, and then now we want to end it with the not T. It's a tuple. Eh. Oh, what? Oh, yeah. Okay, fine. Because it still has that index. All right, let's see if it's fast enough now. I am not very smart today. Even knowing the answer, I cannot even do it. All right, let's see if it's fast enough. It takes 1.8 seconds. But this is crap if it's not fast enough. It's just Leetcode things. Because I'm relatively sure I saw something similar, though maybe implemented another way in C++. Let me see if I can get this to work in C++ real quick. But yeah, this is actually pretty crappy, if that's the case. Because this is now, I mean, I guess there's a sorting, but and I do make things complicated a little bit, but maybe the implementation is just terrible, which is also true. Does this even compile? It does. All right. So yeah, again, I don't know. Maybe it's just a Python thing, but I thought I saw something. Let's see. Yeah. So this is basically the same idea. Right? Like, I don't know. I know that I wrote a lot more, and they don't even need a lot of these. They even do anything of the count. And actually, I guess I don't even need to do the count anymore. Now that we do it this way, the next 0, the counts don't even matter anymore. So we can actually remove it and maybe save some time. It's very wow. It saves actually like a quarter of the time, so actually that is significant. But it is still wild that, like, you know, C++ can do it, but not Python. I mean, the way I still do this is a little bit funky, but I don't know. It's just, this is the same complexity. Oh, so this does accept. Okay, well. But like, how can you tell that, you know, just a little bit faster is good enough? Who knows? They probably fine. Anyway, but yeah, this is all I have for this solution, this version of solution. The other one is with sliding window. There are a couple of ways you can think about this. Let me bring up the drawing real quick. And this is one of the sliding windows that apparently I'm weaker at, and this is not this drawing. What I want to call it like a variable sliding window, because the way that I always think about is with contributions these days, but I think this one's a little bit tricky. But the idea here is that, okay, so you have the entire array, you have a small chunk of it, and then the question is that, okay, so given this small chunk has some number, you know, the XOR sum is going to be some t is equal to the XOR sum, oh sorry, bitwise and sum, right? I don't even know anymore. And the thing is that you have some target k, right? And basically, if t is greater than k, then what happens? If t is greater than k, then you want to shrink, right? Because that means that it's too big, so you always want to shrink from the left, right? So then, let me draw it a little bit cleaner. So then you always shrink. If t is less than k, that means, wait. I messed up. Sorry, friends. If t is greater than k, that means that we want a smaller t, right? And we want a smaller t by adding another number, because that makes t smaller, right? And of course, by adding this number t, this is actually this is actually the smallest number that has this index. Okay, I can write. I'm just gonna say it. All right, sorry, friends. But yeah, but basically, this is gonna be the smallest number that has this index as the last element, right? Because then now the other case is if you have, because like now you have this thing, and now t is less than k, so you want to make t bigger to see if it gets closer to k, right? Because if you remove a number, then there's only two possibilities, right? All right, let me go over it for this case first. So if t is greater than k, then there are two possibilities when you add a number. It is that t is still greater than k, but that also means that, or new t prime is greater than k, but that means that t prime is now closer to k, right? I hope that makes sense, because if t is bigger than k and t is greater than t prime, you have this relationship, right? And in this case, obviously, this is going to give you a closer answer, so that's good. And then the other case is that t prime is less than k. So here you have t is greater than k, and also t prime is greater than k, or maybe equal to. So, but for the purpose of this, but that's fine because that means that now one of the two numbers will be closer to k, right? Given that this is the last element added. So yeah. But then now here, if the number is t is less than k, then you want a bigger number. To get a bigger number, you have to shrink. You shrink by removing from the left side, right? And then here, then there are also two cases, right? You have t prime is greater than k, or t prime is less than k. Because here you get a bigger number, that means that t is less than t prime, k in this case. And in this case, then this is going to be the closer number, so that's good. You have a more optimal idea. In this case, you might not have a more optimal idea, but you have the other side of k to get a possible answer. And that's really the idea about order movements. I think there's a special case which we'll go over in a sec, but that's really the idea. And here, there are two ways to do this. The one is kind of you could do it incrementally, and the incremental way is just by counting the counts bit by bit and doing it loop by loop. I think I don't need this. It gets counted in the next one, I think. That's why we don't need it. Well, we have very funky answers, so maybe I should just mess with it. I don't know. This is not the clean solution anyway, I don't think. Actually, I don't know why. We can remove this. And then just remove this. Because then it just gets executed in the next loop. Here. I don't know. But the idea here is that you have this invariant, which is counts. So counts will tell you the number of ones within that span left and right. And then you just do the same thing with what I told you. But another way to do it, which is I think is cleaner because I made a lot of mistake writing this code, is just do the same thing. But now we use the prefix sum count idea. And then now you can see that our if statements are just going to the right and going to the left, right? So we start with left as you go to right. We have right is less than n. We calculate the current number, which we can, and then we see if it's good. And then now we move, which is that if the current number is bigger than k, then we move to the right side to make it smaller. Right? Make current smaller. Let's put it in here. And then here, if left is less than right, then we make current larger. Remember, current is smaller than k, or equal to. Otherwise, otherwise this is just no elements, right? 0 elements. So just add 1 element because, well, if it's not 0 element, then it's just not. This is right? I don't know how this works anymore. And then at the very end, current is going to be current is going to be right. So now we want to. I don't know why I wrote it this way. Hopefully that still works. I don't know anymore. But yeah, but basically here is, so right is equal to n. So then now we want to shrink left to consider the remaining possibilities. And shrinking left, of course, just makes the number bigger, right? So then just kind of brute force counting it all the way to the end. You can't make the number smaller anymore by adding numbers. So that's basically the idea. Yeah. And this is going to be O of n because right increments n times, left increments n times, and this is O of b. So this is going to be O of b times n, where b is the number of bits. Again, we have the prefix sum here, count here, and that's pretty much it. You could watch me solve it live next. The live part is a little bit long because I explore a lot of these ideas, and you could see me exploring a lot of these ideas during the post contest. And that's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye. All right, YOLO. Okay. Why did I? Wow, people already finished. Well, I mean, not surprised. It's just very weird. Okay, nums. K and the bitwise end of the suburb as small as possible. What is the absolute K and the bitwise end of the subarray? Okay, so basically this has 4. Well, people already got it. That's very fast. Well, I mean, I spent too long on Q2. I think this wasn't that bad, but. Okay. I mean, it feels like sliding window. Because as you grow. Yeah, I think this is just sliding window. You do it twice. Oh, wait. You can remove an end that you. Oh, yeah, okay, yeah. I mean, we've done this before. Oh, yes. This is the actual thing. Okay, yeah, focus Larry. If X. Then. Okay, and then now if absolute difference, okay. I guess this is fine. Anyway, okay, so then now current is going to be less than k, and we're Gucci. It's not good enough yet though, but and then you have to do another loop with another thing. Why? I mean, it should give me something, or maybe only for like the last case. Maybe. Back to unknown errors. Why is that? I have to do non-empty though. Huh? Today's just not my day. Why is it not printing anything? Am I being weird? And what am I doing, Larry? What are you doing here? What are you doing? Okay. This has to be one. Why is it? How is it even possible that it's whatever? Huh? How is that 021? Maybe I'm just putting too much random stuff, but it's an N. Oh, it's an N. Okay, I am dumb. I did an or. Okay. Okay, I mean, that is what I expect from one of them anyway. This should be a 2, 1 and 2 is going to be smaller. Okay, yeah, that makes sense. Then how does this make sense? No, it only gets bigger. How is less than k? Oh no, this made one infinite loop or whatever. Okay, so we take 1. And then let's look at 3, it's too small, so we shrink. No, I'm doing it wrong, that's why. This is for left. Okay, so then now we have this thing. Whatever. And now if it's too small, or rather if it's too big, we just keep on growing. Hmm. 1 and 2 is going to be 0. Oh, no. Man, I am not smart. Probably should have done a. Can I do a binary search? Well, I guess if a segment tree or something, but I don't want to do it that way. Am I messing up my sliding window? So on left. Okay, so we have current thing. If it's too small, we want to. I don't get it. If it's too small, we want to shrink. No, it's too large if we want to shrink, right? Why was my original one wrong? Okay, and then we have this stuff. Yeah. And then we have a left. And then if it's too small, we have to shrink the left. And of course, why doesn't this work? I don't think this makes sense. Maybe it does. Yeah, YOLO submit. I'm not confident about this, but I feel like I want to get a wrong answer to see what the wrong answer is. Though if it times out, that will also be sad, of course. Expected 1, so okay. One is because, oh, just a 6, right? Okay. So 10 Oh, I see. I did actually know this case. Not this exactly, but I forgot how to reset it. Why am I so dumb today? Maybe it's not sliding window. Maybe it's just binary search. Yeah, maybe it's binary search. Maybe sliding windows was a little bit silly. I knew binary search would work, but I thought that maybe I could get this to work. Maybe that was just dumb. Right. I'm not a smart man today. But oh well. Good, what's good mean? Good means that it is the number or bigger. So if this is the number or bigger, then we want a smaller number. So that means that we want to add more numbers. So then left is equal to mid. Okay, so that means that this is going to be the first number where it's going to be equal to or bigger. So we want to try the smaller number as well. Okay, fine. Right. This is -1. No, this because it is +1, not -1. And then, no, this is fine then. Nope, the other way. Oh no, this is the other way. Left is the answer, but yeah. It's k +1. K minus I. $1091 if it doesn't stop being pending anyway. All right, I mean, that's something. So the 0 is 1, 1 to 2 is 0. Is that right? Why? I mean, this is 0, but why is it not just keeping on 1? With 0, this is too small. Okay. Oh, because if it's greater than or equal to that, then we. This running thing is just taking too long. One is 2, 2 is 4, 2 3 is 4. I guess that's true. 3 is 5. That's fine. But this, I don't know that there's any binary search on this. 0 is 1. 1 is 2. Oh, I use k here. That's why k is a little bit funky. I am dumb. That's why k. I don't know anymore. I'm not a smart boy. Oh no, this is k. Alright, 1091. It looks okay at least. That's YOLO. I think it's possible I have an off by 1 on how I handled this. It would be nice if we could actually submit though. Or test or anything. this is the most sus part because I'm not thinking it correctly. Yeah, okay, fine. I'm a little bit tilted by the lag on this bit. I want to be close to 10. The answer is expected answer is 3. Three to 4, 16, okay, 49. Where do you get the 2 from? 0, 0 is 5. What's 5 and 13? I need a... That's 5 apparently. I should have maybe done that, but 1, 2 is 8. Did I do the wrong direction? Can I do it without this? Maybe I just did it in the wrong direction. My off by ones are killing me. Yeah, maybe. Let's just leave it in, and we'll be timeout. It's because I suck at binary search today. I'm just not thinking. Just so tilted by the server issues a little bit, which is not good, to be honest. I mean, like that I cannot, you know, maintain it. But yeah, this is what happens. I don't know, right? Because like, does this make it a little bit okay? I don't know, right? Especially since server's having issues. But I don't even. Like if we have is it that slow? I don't think so. So it's just like very weird. Let me just get ChatGPT up. Apparently it is pretty slow. Is this a... I mean, I legit have issues with my I mean, my performance is not great here either. For sure. Where's current? That's not good. That's really fast. Let's just say. Would that be fast enough? Hmm. Maybe I don't know. Oh, it's 100,000 times 32, right? Maybe I need to, maybe I just don't know how to solve this. I kind of YOLO submitted on C++, but maybe it still times out. Then maybe I have to think of another idea. Okay, maybe I'm wrong. Maybe it's just C++, Python stuff. Let's take a look at the submission time though. I'm still not confident about this one. Oh, doesn't tell me the runtime. I guess system is having issues right now. But can't even debug this, or wanting to debug it. Is there another way? I mean, I feel like there is a sliding window way, but I'm not doing it quite right. Yeah, I mean, the server is just having issues in general. I think there's a way to also not binary search. I think there's a clever thing. The observation here is that it can only change 32 times. So if you are able to keep track of the next change, but I guess you only keep track of the next change by the ways of binary search. Maybe, yeah. I mean, I think there's a non-binary search version, but people did well though. I mean, I don't feel like I did pretty okay, but maybe not. Maybe I was wrong in thinking that I did pretty okay. People did way quickly on this one. Is this Googleable? I'm just, well, I mean, I always solved it and maybe too late. Apparently it is Googleable, so. So there is a sliding window one, but I think I was just wrong on the sliding window. So I think that's probably why. But also apparently it's very Googleable. So Why was I wrong? But yeah, apparently you could Google it, so that's why a lot of people got it, I suppose. Which is kind of a little bit crappy, but it is what it is. So I have this thing. Yeah, I guess I'm not. I think. Okay, let's see, right? So maybe the idea is just to keep growing if we can, right? So that means how do we do it starting with this? So if the target is less than if okay, let's just say we have this, right? So then if current is greater than target, then we want to shrink by no, we want to shrink by removing left, right? Oh no. If it's bigger, then we want to increase right. So then we do yeah. What is going on here? Oh, I see. Otherwise, if it is smaller than that, then we want to shrink to the left, right? If left which is what I have here. I just didn't get my conditions quite right, I suppose. And then else, we expand because we have to expand anyway. What was I was off by a little bit, I suppose. Except I forgot to oh, that's just not right. This is a tricky sliding window. I always feel like, and this I've probably gotten this wrong answer before, but what, did I do something funky? Because 13.9 is whatever, but okay, so then now this is why did I print left? Oh no, okay, so 0 1 after it adds 1. Why is it 5? Or why is it, oh no, huh? Oh, because we incremented right. No, that still doesn't make sense. Where does the 1 come from? One one is 0, so that means I've done some funky things. Right is 0, okay. So once it starts, it's going to increment this thing, right? How do you get 0 1 1? What? I know that this gets incremented, but let's do a pre. Do I not? No, there's a left increment here. Did I use K somewhere by accident? That happens a few times. Okay, 0 0 and then 0 1 1. Why did I print this twice? Oh no, it's just there was 2 inputs. Okay, so 0 1 for I was looking at the wrong input. Okay. That's curious. Oh, because this is after we increment right, it is not inclusive anymore. Huh. So right is exclusive, so that means that this number is wrong, which is very funky. Yeah, I wasn't this part of the. No, I had this input earlier, but I just was too lazy to type it in. Yeah, the sliding window, I don't know. Why? My answer is 3. So 1 is 1, okay. 1 1 is 0 is probably wrong. Oh no, because 1 is exclusive at this point. Okay, fine. Wait, what? Wait, but you get 1. Why would you subtract? 1 is too small, so because it's too small, so we just shrink. Okay, that makes sense actually. So 1, 1 is 0, and then it resets, and for some reason we have this number. 1, 2 is 10. That's fine, and then 10 is too big. 10 is bigger than 7. So then now we want to expand, right? We're going to expand to 3, so 1, 3 is 2. Okay. But the problem is that then now we don't shrink left. So then now 1 3 is 2, so it's too small, but then this already terminates. Right? I don't know if this helps. Nope. This should be an or anyway. I don't know that that helps enough. Because it's still... Why though? Oh, because we want it. But it should be too small though. 110 is 2. Right? Then this terminates. Man, I am like the idea is not that hard, but I'm just struggling a lot today. Maybe I need to practice this. 110. 1, 2 is going to be 1, 2 is 10, so it's 2, and it expands, and then now it needs to shrink. But then maybe I can put another loop. This is really sad the way I'm doing it. Yeah, maybe it's fine, but I don't know. I feel like I'm not writing good code today, for sure. Why? Why doesn't this work? Oh. Is this one? Why is kernel always 0? Why am I so bad? 1.3 has that's just not right, right? Still not running. Okay, so this is good. And now, oh, this is before the left increment. Then now 2 should be 6, right? And this looks like 6. That's okay, so this should be 6. 2, 3. Okay, so this should really be this. Oh. Okay, so this is in 1.3 coming in. It is a 2. And then now, after taking away one of the things, this should be a 6. But left is still. Why is this so weird looking? Like I can hack this to be right, but it just feels so weird. I'm just like not just struggling with how to implement this. I need to rethink and practice how you solve this. It's definitely not ideal. Yeah, I mean, I guess that's why, but why am I struggling so much with how I implement this? That I don't know. Mm. Huh. I mean, another way I could win this is actually use the same thing that I did on the time limit case. Right, and then now So if this is that inclusively, then yeah. I don't need to do all this. Just so error prone. Okay, let's take a look why this goes out of bounds. Maybe that's a better examination. This doesn't do anything anymore. Right, so okay, if this is too big, we go to the right. That's fine. This is too small. Why does this go out of bounds? Line 38. Oh, it's on this part. I guess that's fair. Because right is now N. I guess this way is much cleaner than the incremental thing that I was doing, assuming is right. I mean, I think the other way is actually technically should run faster, but this is a little bit cleaner, obviously. Yeah, this is slower, but that's intentional. Well, I mean, I wouldn't say it's intentional, but we knew that that was the case. I don't know, I'm just kind of sloppy. I feel like this is pretty straightforward sliding window, but I didn't really think about it. I mean, I did, but I was trying to do it in terms of contribution, and I think that was not the right time to use it. I mean, you can still, it's just that you do the binary search one, which I did. But this kind of sliding window, I don't know, today I'm just not really good about it, clearly. Even if I had gotten this, I would have missed this for sure. So I feel like I'm writing this in a very weird way. That's why I don't feel good about it. Because I would have missed this case, and I did miss this case, in fact. I had to, yeah, I mean, I definitely missed this case. I don't know. It's a very weird situation. I hope they don't count it, but I mean, I don't care either way, to be honest. I just didn't perform. But also that it turns out you can't Google this, so it's a little bit silly. I did get a hint in that regard, in that I didn't look at the answer. I just saw that it can be sliding window, so I've tried to figure it out from then. So it was a little bit of upself, because I wasn't sure, because the way that I did it, I didn't have it's greedy, but I couldn't prove it in a good way. But apparently this is fine. So yeah. Anyway, that's what I have for this one. That's what I have for this contest. Let me know what you. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.